Hello, welcome to this video. In this video, we will explain a machine learning model using an explainability technique called SHAP. For this video, we are using a random forest model. To understand a random forest model, we first need to know what a decision tree is. For example, you're hungry and want to eat something. You see this. If this is an apple, then eat it. Here, it looks like an apple, but it's not, so don't eat it. This is a simple decision tree. Multiple numbers of decision trees make a random forest model. We are going to see how a random forest model works and how the predictions from it can be explained. For that, we have taken the famous Titanic dataset here to predict the survival odds on the Titanic. This is the sample dataset with 5 samples. So what happens now is that to train the random forest model, we will create a new dataset from this by randomly selecting samples from it. Note, the samples can be repeated. Now we randomly select samples to form a new dataset. As you can see here, sample 3 has been repeated twice. Now that we have the new dataset, what we do with this new dataset is train the model with it by feeding these inputs into decision trees. We do that by randomly selecting any feature from the new dataset. Let's say we selected the feature age as the primary node. The other nodes are also randomly selected. So now the first tree is built. Similarly, we repeat this step to build many trees. Now the model is trained with this dataset. Now it's time to test the model. Let's take a new sample to test the model. Here we have all the variables and want to see if the passenger will survive. We take this data and input it into the trees that we'll build and find out if the passenger survived. For each sample, the variables are run through all the trees. And let's say we had 10 trees. How many trees predicted the passenger survived and how many did not? 9 trees predicted the passenger would survive and 1 predicted the passenger wouldn't survive. 9 being the highest number of votes, we conclude the passenger survives. With just 5 samples, it can be understood how the decision was made and why. But usually the data set is much more extensive and explaining it this way would be difficult. Let's say our data set has 712 samples. And to explain this model will be much more difficult, which is why some machine learning models are called black boxes. But in this video, we will explain how we can understand such complex models. First, we will split the dataset into trained dataset and test dataset. A random forest model is trained with this dataset. Now, we test whether a passenger will survive or not by taking one sample and running it through the model. The random forest checks this and predicts that the passenger will not survive. But how did the model come to this conclusion? To understand this, we have explainability techniques in machine learning to explain. We can use the SHAP techniques to explain this. What SHAP does is find out how much each feature contributed to the prediction. SHAP values are based on shapely values, a concept coming from game theory. The example we took from the model is the games and the features are the players. Now let's see how we can understand the model's prediction using SHAP. Before seeing how each feature contributed, we must understand a base value. What is a base value? So this is the training data set and the outcomes for each of these samples are all averaged together to get the base value. Finally, we will see a plot done by the SHAP to understand how the prediction was made. All the features marked in blue have contributed negatively for the passenger. For example, the feature sex is represented as 1, which is male, and it has decreased the chances of survival for the passenger. The feature in pink has contributed positively to the passenger. SIB-SP means having siblings or spouses. Since the passenger had none, it increased his chances of survival. But unfortunately, the predicted value is less than the base value, which is why the passenger did not survive. This is how a prediction for complex black box models can be explained. We have another video where we have explained neural network model. Please have a look at it. Link is available in the survey. Thank you for watching. This video is followed by survey questions regarding this explanation. Please do answer. Thank you.